data survey, which I call the Survey of Rural Road Impacts in Vietnam, the SURV, we did a baseline pre-project in 1997, and then follow-up rounds every 2 years after that until 2003. There's 100 treatment communes and 100 comparison communes. Here we take the commune as the zone of influence for the road. So typically in Vietnam, the center of the commune has the school and the markets and all those kinds of things. And these roads typically went from linked up the center of the commune to the road network. We also surveyed 15 households in each commune, and here we picked. They had welfare rankings, and we picked 5 households from the bottom third, 5 from the middle third, and 5 from the top third. So they should represent distribution of income well. So this gives us a panel of 200 communes and 3,000 households. There's also a project database with all the information on the project, when it was done, what it did, and so on. Now, one of the things I regret is that there's no welfare indicator, so no consumption measure or income measure. However, we designed the survey so that we could link it up with the Vietnam Living Standards Measurement Survey of 1998, and we actually calibrate a consumption model. We use a consumption model calibrated on the VLSS to predict household consumption for all the households in the SURV. Which seems to work quite well, but of course, has may have a lot of problems. It's hard to tell. As I noted, there are likely to be differences between the project and the chosen non-project communes. These were chosen to be as similar as possible to the project communes in the same districts, but far enough so that minimize the possibility of spillover effects. But despite the fact that they were chosen to be similar, they're still likely to be different, and so there's an endogeneity issue. And so we used the double difference with propensity score matching to deal with these issues. The double difference, the difference in outcomes over time between project and non-project communes should get rid of the additive time invariant observables and unobservables, so that it deals with the time invariant selection bias. And then the propensity score matching is essentially a way to try to select ideal comparison groups amongst the groups that amongst the communes that we have data for. So to make sure that they're as similar as possible. And this basically uses the baseline characteristics that are likely to affect selection into the project as well as outcomes. It uses a logit model, so where you just pool the 2 samples, the project and non-project communes, and you run a logit of, it's 1 for if you were a project, 0 if you're not, against all the initial conditions that you think could affect both placement and outcomes. And that gives you a predicted propensity, what's called the propensity score. It's really the probability of having been chosen or allocated the project. And that propensity score is then used in different estimators. Okay. Now, you can trim samples if there's some communes that are outside what's called the common support, some communes that clearly don't have any good comparators. And we end up with 94 project communes and 95 non-project communes. We use 2 impact estimators, in part just for sensitivity. A non-parametric kernel matching is one, where all non-project communes are used and as comparisons, and they're weighted according to a kernel function of the predicted propensity scores. And then an alternative is to use the propensity scores to weight the double difference. Now, this is going to give unbiased estimates of project impacts, unless, of course, there are omitted, unobserved characteristics that are time variant and correlated with both placement and outcomes. And you can never really rule this out. When we thought about it for so much, it's hard for us to think about what those could be, those unobservables that mattered both to placement and outcomes, but you can never rule it out. So, okay, now, how am I doing on time? Okay. Just very quickly, in this paper that was distributed, as I said, we look at a large number of outcome indicators. This makes it very complicated to both present and interpret. And a lot of these indicators basically are measuring similar things. You know, we have a number of indicators for transport. For example, whether there's freight transport, whether there's passenger transport, whether bus frequency has improved. So many things trying to get at the same thing. And so we wanted to basically reduce the dimensionality of this. And to do that, we use a mimic model, which is a multiple indicator, multiple cause model. A lot of people don't like this. It's really using factor analytic methods to reduce the dimensionality and to link indices to the attributes to look at the heterogeneity. So essentially, the mimic combines a measurement model that groups related outcome estimates into an index and a structural model that models how the initial attributes of the communes influence that impact index. I think in our new version, we're going to abandon this, and when we just use a simple OLS, we get very similar results. So, okay, let's get to the results. So, as I said, we've examined a large set of local area and market development related outcome variables. We see when you eyeball the data in over time, and you see that all of these basically go in the right directions. They improve over time in both project and non-project areas. And so the key question is, is there a differential impact in the places that got road improvements? Okay. I swear the bullets, they just have a mind of their own. I really didn't color the bullets different colors or sizes or whatever. I don't know. Anyway. Okay, what do we find? By 2001, we find some significant impacts on the availability of goods in the markets, food goods. Okay, so we look at a wide, we can't look at prices because in 1997, in our baseline, a lot of goods are missing in the markets. So we have a very incomplete data on prices, basically. And so what we can do is see whether goods went from never being available or sometimes available to always being available. And that's essentially what we look at. And we see that there are quite a few significant impacts on food items by 2001. Otherwise, by 2001, the only other real impact is on primary school completion rates, which went up in a sustained fashion in 2001 and 2003. In fact, that's probably the most significant and substantial impact that we get. By 2003, we see some impact on markets and market frequency. Markets went up in about 10% of project communes got markets that didn't have them before, 10% more than the non-project. And the frequency of markets, the number of times in the week that they that they were held also went up by about 25% more. So that's quite strong. Now, we also see a reduction in the percentage of households that do only agriculture, whose main occupation is only agriculture. It's a small percentage, but we start off with almost everybody. I mean, it's absolutely, 99.9% were agricultural households. And so there's some sign of diversification. It seems that there's also an increase in the percentage of households that were involved in services. So that seems to be what's happened. We find significant impacts on the availability of services such as tailoring and hairdressing. What else? I think those are really the main impacts. Some on production inputs as well, on gasoline and fertilizer. But on the whole, I have to say that we don't find huge impacts. I mean, there are a lot of outcome variables where there's just no impact. Now, and I think this is in contrast to a lot of papers on rural roads that find very high impacts. One issue is that the average impacts, averaged over all the communes, may hide a lot of heterogeneity, and so that's the next thing we look at. And we do indeed find that there is a lot of heterogeneity across communes, so impacts differ a lot. And one way to look at this is whether they differ across poor and non-poor communes. So we did this. What we did was use the predicted household consumption to calculate, to separate the communes, the project communes, into two groups, the ones below and above the median predicted household consumption. And we then calculate mean impacts for those two groups. Yeah? And here we find really pronounced differences in impacts, with impacts generally substantially larger in poorer communes. You can see that here. So on the vertical axis, we've got the mean impacts for the poorer communes. Yeah? So note that it's negative here, yeah, positive there. And then this is for the non-poor, so negative here, positive there. Now, the key thing I think to note here is that the bulk of impacts for poor communes are positive, and they tend to be substantially larger than for the non-poor communes. Yeah? Now, yeah.
The line has a slope of 1, right?
This is the 45-degree line. So, yeah. So along there, they'd be the same. There are very few that are along there. Yeah? Now, there's problems with statistical precision here of these impact estimates and so on. I think that the lesson or the general thing to take from this is simply that impacts tend to be larger for the non-poor. If you look at the northeast quadrant, about 36% of the observations fall there, so that they're positive for the poor and negative for the non-poor. Did you have a question?
I was going to ask which was the monster outlier.
Yeah, I was wondering that myself when I was preparing this, and I can't remember. If we take that out, there's absolutely no correlation. With that, it's like 0.37 or something, but yeah. Okay, so that's quite, I think, quite a strong result. And so the next question is, what is it about poor communes, that results in this? And we find that the poor communes have very different attributes, and these tend to be worse attributes, or certainly attributes that are typically considered to be disadvantageous. Poor communes are much more likely to be in mountainous areas, and much more likely to have high ethnic minorities shares. higher adult illiteracy, much further away from the closest market. The only really positive thing here is that they have a lower prevalence of weather shocks than the non-poor communes, in part because they're more in the mountains where you have less problems with weather, which is mostly coastal in Vietnam, the big floods and typhoons and so on. So the key difference. So here you see that the differences tend to be significant. 2 stars is significant at the 5% level, 1 10%. And so the key question then is really, what are these initial conditions doing? What's the role of them in determining the road impacts? And so then that's when we use the mimic model to try to see what's happening. We regroup the commune level impacts into 11 local area development outcomes and 9 outcomes related to goods and services availability. And we try to explain them with initial pre-project community characteristics. Okay? Now, what do we find? Well, we find that there's considerable impact heterogeneity and that those impacts are highly context-specific. We find that the impacts are clearly the result of how attributes of places and people interact with what the project does. This is a highly complex picture. It's not something easily summarized and easily fed into policy. We find that impacts are generally higher in poorer areas, which tend to also have conditions favoring higher impacts. So we find decreasing returns. So marginal returns are higher when the outcome is initially lower in a commune, which is consistent with impacts being higher in poor communes. Some commune attributes, such as adult illiteracy, tend to always be bad for consistently reduce the impacts of improved roads across different outcomes. That's true also of weather shocks. Clearly, roads don't help, with that kind of constraint. The share of ethnic minorities, again, tends to reduce impacts. Ethnic minorities in Vietnam, a lot of the ones in the mountainous areas are very culturally don't participate in markets, and I think it's consistent with what we're finding here. Other attributes are consistently good for impacts. One of these is mountainous areas. It's kind of fits one's intuition that roads will help with the problems caused by mountains. Another one is the share of households with motorcycles. This also helps take advantage of the new road. And then there are other attributes that basically sometimes help for certain outcomes and sometimes reduce impacts for certain outcomes. So these are the population density and the distance to the closest city and markets. So it's really the combination of attributes that seems to matter. So just to conclude, we find that different communities have very different opportunities or capabilities to benefit from road improvements. We found that poorer communes tended to benefit more, reflecting this a tendency for decreasing returns. While poorer communes benefited more, they also have attributes that tend to reduce impacts. Yeah, so basically, mountainous areas tends to improve impacts or have higher impacts. But in Vietnam, in many of the mountainous areas are also the areas that have a high share of ethnic minorities and also have where there's high illiteracy and so on. So in a sense, you have a combination of attributes that both increase the impact or are good for impacts and attributes that lower them. So it's really the combination of commune attributes and how they interact with the road improvement that seems to be key to understanding the impacts, which makes us quite skeptical about finding a simple formula for where roads should be placed. These results are very complex, very all over the place, and that's why we've decided we're going to try to model this a little more, to put a little more structure on it and try to understand how some of these things, such as the distance and the attributes, lead to certain outcomes. Thank you.